Hello, 8th grade math students. Mr. Lawrence here, and this is video number 1. Yeah, don't know how long we're going to be doing these things, but I got to tell you, those of you that are logging in, watching them, and doing your best with them, you are going to be so far ahead of the other kids that choose not to go in when we get back and next year, more importantly, because this is so algebra heavy. All right, anyway, enough of my preaching. Let's get on with it. Remember, I'm going to have office hours 10 to 11 for your class every day, so please stop in. Okay, now I want to graph these linear equations. I actually have 3 of them set up for you to do. Okay, I want you to try to graph this one on your own. Just pause the video and give it a shot, all right? I'm going to ready to graph it now. If you haven't done so, please pause the video and try. All right, here I go. Since y is already alone, I know I'm in what's called slope-intercept form, which means I know the slope and I know the y-intercept. So my y-intercept is 5, and I want to put that on the graph right away. Notice I put it on the y-axis, not over here. This is not the y-intercept, no way. It's got to be on the y-axis. And then my slope is negative 2/3. So from this point, the y-intercept, I'm going to rise negative 2 and run 1, 2, 3. There we go. I'll do it again. 1, 2, 1, 2, 3. Okay, if I wanted to, I could have used a slope of negative 2/3 like that, where the rise is positive 2 and the run is negative 3. If I rise 1, 2, and then run 1, 2, 3 to the left, rise 1, 2, run 1, 2, 3 to the left, you see that the line I get is the same exact line. It works the same either way. And so, now remember, just drawing a little segment from point to point isn't what we're about. We're drawing lines that go forever. We're not playing connect the dots. So there you go. Put arrowheads on both sides and make it take up the graph. Okay, this one's a little bit more challenging, but again, I'm going to pause. I want you to pause the video and try it on your own. You don't learn by watching, you must do, and this isn't the first time we've been doing this, so you should give it a shot. Okay, I'm getting ready to show you how to do it. If you haven't tried yet, please do so. All right, well, my first goal is to get y alone. Yes, I've got to have the y all by itself. And I ask myself, what numbers are attached to the y? Well, I see a 4x, and it's attached by addition, not because of this, but because it's a positive 4x, right? And then I also have a 7, which is attached by multiplication. I need to go reverse order of inverse operations, so I'm going to undo subtraction and addition before I undo division and multiplication. So to undo the addition, I'm going to subtract 4x from both sides. Now on the right-hand side, notice I did not line them up. They are not like terms. Do not line them up. Okay, these have canceled out. I'm left with a 7y. That's going to equal negative 4x plus 56. Why plus? Because it's a positive 56. Okay? All right, now the 7 was attached by multiplication, so I'm going to use division. But I have to divide all 3 terms by 7. Not just 2 of the terms, all 3 of them. And when I do that, I'm going to get y equals negative 4/7 x plus 8. So now I'm ready to graph, okay? I've got my y-intercept of 8. How do I know this? Because I'm in slope-intercept form. How do I know I'm in slope-intercept form? Because y is alone. Now my slope is negative 4/7. All right, so I'll go to positive 8, which is right there. And then I'll go down 1, 2, 3, 4. And then to the right, 4, 5, 6, 7, right there. Okay, now I can't really get any other points on the graph that I'm using accurately, so I'm going to do the best I can with just these 2 points. Normally I like to put, 3, 4, 5 points on so I can draw a more accurate line. But in this case, that just simply wasn't going to work as well. So, and I need an arrowhead on there, right? Okay, notice my line is extending beyond the points and each end has arrowheads. All right, one more sample problem for you. It actually has 2 graphs on it. Again, I want you to pause the video and then watch for mine. See if I do it the same way you do. Okay, I'm getting ready to do it. First, I want you to pause the video if you haven't already done that. Okay, y equals -2. Well, I remember Mr. Lawrence saying that's a horizontal line. And every y coordinate is going to be -2. And that's absolutely true. Now, if you didn't want to do it that way, you could say, well, y is alone, so I'm in slope-intercept form. What's the y-intercept? Well, it better be -2 because there's 0 x's in the equation. And since there are 0 x's, slope must be 0 or 0/1. So I'll go to -2, rise 0, run 1, rise 0, run 1, rise 0, run 1, and I believe you can see that all those points I just plotted, they all have a y-coordinate of -2. Okay, y equals a number is a horizontal line. Its y-coordinate is that number. There is no exception to that rule. Okay, for the blue one is a vertical line. Yeah, this one's a vertical line. It doesn't have slope, and most vertical lines won't have a y-intercept. I can only think of one that does. But I do know that every x-coordinate for every point on this line is going to be 1. How do I know that? Because the equation says x equals 1. So maybe I'll put 0, 2, and -3 on there. So 1, 0 is right here. 1, 2 is right there, and 1, -3 is right there. And so my vertical line is going to do this. And again, I'm not just drawing a segment, I'm making it take up a good portion of the graph, putting arrowheads on both ends, and there we go. All right, that's it for the video. You should watch this, give the homework a shot. It's a worksheet, it's already posted. And then please come on for office hours between 10 and 11 to see if you have any questions. All right, Mr. Lawrence signing off. Have a good day, everybody.